Okay, we're going to begin today our last lesson of the chapter, you guys, which will be today that we're going to be learning about determining relations. So today's two learning targets that you will be learning about is, after this lesson you will be able to describe if a relation is a function, and you will be learning about learning target 1D, which is, after this you'll be able to describe the domain and range of a function. Okay? So before we start, let me define what a relation is. A relation is any pairing of a set of inputs, your x's, with a set of outputs, your y's. Okay, I will give you a moment to write that down and then we'll continue. Let's continue. Okay, so I'll give you a moment to write this down and then we'll continue. Alright, so you can represent the relation in different ways. So you're going to be seeing a relation being described in a lot of different ways. So the first way is you're going to see a mapping. So you might see these right here. These will be your inputs. And then these right here are your outputs. So if you see that arrow right there, you guys, it's going from inputs to outputs. Okay, so in other words, just to make it easy for ourselves, these are our x's and then these are our y's. Okay, so let's continue from there. Let's see if we could make a table of values out of this mapping. Okay, so with our table of values, we know that we have our x's and we have our y's. So first, let's take a look at our -3. Our -3 is an x and it's pointing to a -2, which is a y. So therefore, we're going to go ahead and put, for our x, we're going to put -3, -2. Let's take a look at our 1 now. Our 1 is pointing to our -1, which is a y. So we're going to go put a 1 and a -1. Now let's look at our 2. Oh, our 2 is pointing to a -1. So remember, you just follow the arrow and you just see what it's pointing. So your 2 is your x and your -1 is a y. So put 2 and -1. And last but not least, your 4 is pointing to a 3. So remember, your 4 is an x and a 3 is your y. And that's how you can make a table of values out of a mapping. Okay? Let's continue from there. Now, what do we want ordered pairs? Because remember, you can represent it different ways. You might see your relations be represented as a mapping, as a table of values, and as ordered pairs. So if we want ordered pairs, let's connect them. So right here, again, whenever you see a table of values, you guys, circle your x and your y. So that's your first pair. We're going to put -3, -2. And again, just to notate this for ourselves, this is our x and this is our y. Okay, very simple. The next one, 1 and -1 is another pair we have right here. So now as an ordered pair, we write 1, -1. Your third one, you have 2 and -1. So therefore, your ordered pair is 2, -1. And last but not least, you have 4 and 3. Again, you circle your pairs right here from your table of values. And last but not least, your point is 4, 3. And again, these are your x's and these are your y's. Now, let's continue from there. Let's see if we could graph them. So first, plot your first point, -3 and -2. So first, remember, this is your x-axis and this is your y-axis. So we're going to plot the first point. So -3, so you go 3 to the left, 1, 2, 3, and then -2 you have to go down 2, so 1, 2. So that's your first point right there. 1, -1. So remember, you go right 1 and then down 1. So this right here is -3, -2, and then this is 1, -1. This point right here, 2, -1, so you go right 2 and then down 1. And then your last point is 4, 3, so you go right 4 and then up 3. So just a little quick review. So you might be wondering, Mr. Rubio, why are we doing this right here? This is to show you that, again, relations can look in different ways. Whenever they give you a relation, you might see it as a mapping, you might see it as a table of values, you might see it in ordered pairs, or you might see it as a graph. Okay? So keep that in mind, and then we'll continue from there. I'll give you a moment to write this down, and then we'll continue. Now, I'm going to show you a definition of what a function is. So a function is a relation that pairs one input, so exactly one input, with an output is going to be a function. Okay? So if you have a relation that has two inputs to an output, that's not a function. Okay? So remember, it has to be exactly one input with an output in order for it to be a function. I'll give you a moment to write that down and then we'll continue. Okay, go ahead and write down example number 1. So ignore the scratching that I had right there. And you're going to be determining whether each relation defines a function. Okay? So write down A, B, and C, and then we'll continue from there. Okay, so again, for something to be a function, it has to be one input. It has to pair one input to an output. Okay, so we're gonna take a look at this. So in other words, you have to have no repeating inputs. No repeating inputs. So you're gonna be looking for that. Okay. In other words, your x's. So first, let's take a look at A. So we have 3 points. We have 2, 3, we have 3, 2, and we have 2, 5. Let's take a look at our x's. What are our x's here? We have 2, 3, and then 2. You see that you have a 2 right here and a 2 right there. So remember, you can't have no repeating inputs. So therefore, this right here is not a function. Okay? So that right there, you guys, is not a function. Okay? Again, you're just looking for if it has repeating x's, then it's not a function. Now let's take a look at this point right here. Let's take a look at our x's. We have -4 and 2. Okay? We have -2 and 3, and we have 4 and 5. Now take a look at it. Our x's is -4, -2, and 4. Now some of you might be wondering, Mr. Rubio, you have 2 4s. However, take a look at it. You have a -4 and you have a 4. Are -4 and 4 the same thing? No, they're not. So does that mean that we have repeating inputs? Absolutely not. So therefore, this is a function. A function, why? Because it has no repeating x's. No repeating x's. Okay. Now let's look at C. Alright, so this is a mapping right here. Remember, these are your inputs and these are your outputs. So this is your x and this is your y. So let's go ahead and make a little table for ourselves. So this right here again. Make a little table for yourself. So your x's and your y's. Okay, first your -4 is pointing to a 1. Your -4, 1. Your second one, -4 and 3. And then your last one, 2 goes to 7, so you have 2 and 7. So now, let's take a look at our x's. We have -4, -4, and 2. We have repeats. We have a -4 and a -4. So, this means right here that this is not, and I repeat, it's not a function. Okay? Okay, let me divide this right here. Why is it not a function? -4 repeats. And there you go. Again, you're just looking for the x's that repeat, and then you go from there. I'll give you a moment to write this down, and then we'll continue. Okay, so now we're going to talk about the vertical line test. Okay, so you're going to have situations, you guys. So as you write this down, gonna go ahead and explain. As you're determining whether relations are functions, you have situations where, again, you're going to have mappings, you're going to have tables of values, you're going to look at ordered pairs. However, just as we saw in example number 1, however, you're going to have times where they're going to give you a graph, and by looking at the graph, you're going to have to determine whether or not it's a function. So therefore, we have this little tool right here that we call the vertical line test. So a graph represents a function when no vertical line passes through more than one point on the graph. Okay? So let's take a look at this graph right here. If you have this graph right here, remember you have, so say these are your points. If I were to draw, if you draw a bunch of vertical lines right here, how many times does it pass through a point? Once. What if I drew one through right here? It only passes through once. What if I drew one through right there? It passes once. Right here, it goes once. Right here, it goes once. So therefore, this is a function, because that right there will be a function because it only passes once. Now, on the other hand, let's take a look at this example. What if this is our graph right here? If I draw my little dashed line, if I take a look at it, it crosses through one point, and then I keep going, it crosses through another point. Now if you notice, it crosses twice. So if it crosses twice, it cannot, and I repeat, it cannot be a function. Okay, that's what the vertical line test says. If you draw a line at any point, okay, if you draw a line at any point, if it crosses the graph more than once, then it's not a function. If at any point it crosses it just once, then it is a function. Okay? Give me a moment to write this down and then we'll continue. Okay. Alright, so I'm going to go ahead and give you a little moment to write this down, this definition, and then we'll continue. Okay, domain and range. So this is the last definition that we're going to be learning for this lesson, and I'm going to introduce to you what a domain is and what a range is. Okay? The domain of a function is the set of all possible input values. Again, in other words, it's all the x's in the function. Okay? Your range of a function is the set of all possible output values, so your y's. Okay? So when you're thinking of domains, think of your x's. When you're thinking of your ranges, think of your y's. Okay? It's very simple, but you will see certain problems in a bit once I present them to you how it works. Okay? So again, your domains are your x's, ranges are y's. Domains are x's, ranges are y's. Memorize that in your head so you don't confuse both of them. Okay? I'll give you a moment to write down this definition and then we'll continue to our last example. Okay, let's continue. So go ahead and write down this example number 2. So draw your graphs. And they're asking us to find the domain and range for the graphs, and then after that we'll determine which graphs are functions. Okay, so I'll give you a moment to write that down and then we'll continue. Okay, so first let's take a look at A. So first they want us to find the domain. Again, a domain is the set of all your x's. Okay, so there are your x values. So let's take a look at it. How many points do we have? We have 1, 2, 3, 4. So, in other words, you guys, we will have to determine what the x values are for each point. Let's take a look at this point. This point is -2, 2. This point right here is 1, 3. Again, because you go right 1 and up 3. This point right here is you go right 1 and then down 2. So therefore it should be 1, -2. And last but not least, this point right here, you go right 3 and down 1. So this gives you 3, -1. Now, your domain. Your domain, again, you guys, is going to be all your x's. So this is an x, your -2. Your 1's an x. Your 1's an x, and your 3's an x. So now I'm going to go ahead and write my domain. So we have -2, 1. Okay, so -2 and 1. We have a repeating 1 right there, but we'll just write that down, and then we have a 3. Now let's look at our range. Again, your range is now, instead of your x's, you guys, your range is going to be your y's. So now let's take a look at our range. So your y is 2, your y is 3, your y is -2, and your y is -1. Then we'll continue from there. Now that's your domain and that's your range. Now let's determine if it's a function. Remember, for a function for it to be a function, there has to be no repeating x's. So let's take a look at it. We have -2, 1, 1. Wow, we have 2 1's. Does that mean that this is a function? No, this is totally not a function. So therefore, that means that it is not a function because we have repeating x's. Repeating x values. Now some of you might be wondering, Mr. Rubio, what if our y's repeat? Does that matter? Could it still be a function? The answer is yes. Remember, you're only looking for repeating x values. The y values, you ignore them. You don't have to figure out whether or not they're repeating. But for your x's, you always want to make sure you check that whether or not they're repeating. Okay? Now let's continue from there. Let's look at B. So now for B. Now this one, you have a line right there. So you might be wondering, Mr. Rubio, like what points do we have? We have 2. Is 2 right there for our domain? Yes. Is 1 right there? Yes. Is 0 right there? Yes. But what about these points in the middle? Okay, so then here's what we're gonna do. Here's what I'm gonna do. Pretend there's a stick figure. Okay? And then you're gonna figure out when you start graphing, okay? So first, okay, we start right here, right? So then you walk right there, you keep going, right? You have all these x values, and then where do we stop? We stop right there. Okay? And if you look at it, watch, your domain covers all these x values. You cover 2, you could cover negative 2, you could cover a negative 1.5. You're pretty much covering all these x values. Okay? Again, if you were to pretend like a stick figure is walking, they could go through all of them. So, if you think about it, there's infinitely many. So therefore, the lowest one we have is negative 2. And then, since this is a whole circle, you have to put is less than or equal to your x, and then you put that is less than or equal to 2. Now, why do we put the less than or equal to? Remember, because these are closed circles, so these right here will cover them. Okay, so that's your domain. Your range, on the other hand, now we have to look at our y's. So first, again, I'm gonna go ahead and draw a little stick figure, but this time it's gonna be walking along the y-axis. So we first walked to the x-axis, now we're gonna walk to the y-axis. So I'm gonna draw my little stick figure, and it's just gonna be walking around the block. So then, think about it. I'm gonna use a different color to distinguish. So right here, we don't cover anything. Oops, but look, we cover something right there. So now, it starts walking. Remember, do we start with y value right there? Yes. So it keeps going, keeps going, keeps going, keeps going. Stop. Why does it stop? Because look, if you think about it, if I keep going, there's no more values over here. So now, it walked pretty much this. Now, again, this is your y's now. So what y value did we start with? We started at negative 1. So we start at negative 1, less than or equal to. Now, be careful right here. For our domain, we said it was our x values because we were walking over here, so we put an x right here. But for our range, what values are these? These are y's. So you put a negative 1 is less than y, and then y is less than or equal to, and where does it stop? What y value did we stop at? We stopped at 3. So we stopped at 3, so therefore that's our range. Okay? Why do we have these inequalities? Because the reason you do that is because you want to make sure that you cover all these points right here, okay? Because if you decided to write like 1.099999 or 2.122, like that's too many points to name. So this is saying that it's all the x's in between negative 2 and 2, and all the y's in between negative 1 and 3. Okay? And now let's determine, last but not least, is this a function? Okay, so let's draw the vertical line test. So we're gonna do the vertical line test. Okay, draw a line right there. Do we cross? How many points do we cross? Once. What about right here? 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 Once. So if I keep drawing multiple lines, you'll realize that it only crosses once. And since it only crosses once, that means that your function, it is in fact a function because of the vertical line test. Okay, remember, if it crosses twice, it's not a function anymore. But remember, it crossed once, and that means it is a function. Okay? With that being said, now what you're going to do is make sure you do this assignment at home. We're going to go ahead and take the quiz now, and I will see you later. And if you have questions, email me. Have a great day.